Alright, in lesson 51 we'll be talking about logarithms. In particular, two special logs, the common logarithm and the natural logarithm. So you know that we can do log base a of something where a can be any number that's larger than 1. But the two most common ones that we will see, that you're going to see on your calculator, are like log, just plain log, that means log base 10, and that's called the common logarithm. And the natural log, which is marked on your calculator with an ln, that is called the natural logarithm, and the base of that one is a crazy number called e. And e is a number that just occurs over and over again in lots of different contexts, and it appeared so many times in natural kinds of problems that they gave it a number, just kind of like pi. Pi just jumps out in nature all over the place, and so they named it. It's a 3.1415, you know, it goes on and on and on. E is a similar kind of number, but it's not 3.14159 blah 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 blah. E is approximately 2.71828, that's as far as I know, 2.71828, and on it goes. Okay, so it's another one of those irrational numbers, but it occurs so often that we give it a special name, e. Okay, and actually if you were to go in your calculator and you want more digits, if you do the second, that's an e, and just raise it to the power of 1, there is our approximation for e right there, 2.718281828, and I think it just keeps repeating that. Okay, so that is what e is. Okay, so our first problem is we'd like to write some number like, let's say, 52,000 as a power of 10, and then write it also as a power of e. Okay, so the first one, writing as a power of 10, that's just simply writing, okay, we want 52,000 to be written as 10 to some power. We want it to be written as a power of 10. So what would the power be that we have to put onto 10? Okay, so how would we figure that out? Well, we could, to solve for x on this side and get it by itself, we would have to take the log on this side. So if we take the common log, or log base 10 of both sides, okay, so think about this. What power would we have to raise 10 to get 10 to the x? Well, of course, we'd have to raise 10 to the x power to get 10 to the x. So this side is x. And to figure out what log base 10 of 52,000 is, we just go and look in our calculator. So we just use, that log is log base 10, that's the common log of 52,000. And we get approximately, I should put approximately because this is going to be rounded, 4.716. Okay. Now, if we had to do and write it as a power of, so I guess we can write this, 52,000 would be 10 to the 4.716 power. And we could go ahead and even check that. Let's do 10 raised to the 4.716 power. Okay, and you see that when we round that, we would get 52,000. Obviously not going to be exact because we had to round our exponent, and so our answer will also be rounded, but it's very, very close. Okay, and if we had to raise e to a power and get 52,000, what would that be? Well, again, this is going to be similar. So 52,000, if we had to raise e to some power of x, well, this time, to figure out and get x by itself, instead of taking log base 10, we're going to take log base e. And that is the natural log. Okay, so think about, this is like log base e. What would we have to raise, what power would we have to raise e to get e to the x? Well, of course, e would have to be raised to the power x to get e to the x. And so this is x. And then the natural log of 52,000 10.859. So that means that 52,000 at least is approximately e to the 10.859. And it makes sense that this would be a lot larger than this because e is only 2.81828. So it's a lot smaller than this, so we'd have to multiply it by itself more times to get that large number. And if we wanted to go ahead and check that, okay, use that second function. That's e to some power, and let's put in our 10.859. And we get something very, very close to 52,000. Okay. Alright. So let's do another one of these. If we had to write 3.7 as a power of 10 and as a power of e, just like before, to write as a power of 10, we just need to find out what log of 3.7 is. Well, log of 3.7 is 0.568. So that means that 3.7 would be 10 to the power 0.568. And notice 3.7 is less than 10, so it makes sense that it would be a fraction. You know, 0.5 would be the square root of 10. The square root of 10 is just a little bit over 3, so it's going to be a little bit bigger than the square root, a little bit more than 0.5 to get that 3.7. Okay. What about as a power of e? Well, we have to do the natural log of 3.7 to write it as a power of e. Okay, and the natural log of 3.7 is 1.308. So 3.7 would be e to the 1.308. And it makes sense that that would be a little bit bigger than 1 because e is only 2.81828. Okay, so it would have to be raised to something larger than the first power. Okay, if we squared it, we'd get, you know, something bigger than, you know, the 2 point, you know, this is bigger than 2.5, so we get something over 6. If this were squared, it's got to be definitely bigger than 1, less than 2, so it seems reasonable. Okay. And now, what about 37,000 as a power of 10? Okay, so again we would do the log base 10 of 37,000. So log of 37,000 is 4.568 approximately, and the natural log of 37,000 would be 10.519. Okay. I do 37,000? Yes. Alright. And so if you look at this, we do see, did I do log of, I was expecting a number. Okay. Okay, so we want to look at the relationship between what we had here, because you notice this 0.568 shows up again here. So let's look at this one. Okay, so 37,000, if we had to rewrite that, that would be like 3.7 times 10 to the 4th in scientific notation, right? So if we were doing log of 3.7 times 10 to the 4th, well, a log of a product is the sum of the individual logs. So that we make log of 3.7 plus log of 10.4, or sorry, 10 to the 4th. So we know from here that log of 3.7 is 0.568. Log of 10 to the fourth is 4. And so it makes sense that we would get 4.568. Okay. So there may be times when they tell you if log 3.7 is blah, without using a calculator, find out what the log of, some related number is. And you should be able to do that using your log rules with logs of products. Okay. Okay, so this one, let's go ahead and just do this one as well. So this would be the natural log of, well, this one doesn't work out so well because we don't have a power of 10. So that's why this one doesn't look, but the powers of 10 should work out nicely. If it was something closer to e's, then, so we don't need to really bother with that one. It's the 10s that are good. Okay, and our last one, let's go ahead and figure out what the log of 0.037 would be without using a calculator for the power of 10. We'll go ahead and do it for e with a calculator because we don't have nice things to figure out. Okay, so 0.037 is the same thing as 3.7 times 10 to the negative 2. Right, because if we just move that back 2 spots. So if we were to find the log base 10 of 3.7 times 10 to the negative 2, the log of this product is just the sum of the individual logs. So that would be log of 3.7 plus log of 10 to the negative 2. We know that log of 3.7, here it is, 0.568. And the common log of 10 to the negative 2 is negative 2. So if we did negative 2 plus 0.568, we would get negative 1.432. Okay, and let's go ahead and check that. If we did 10 to the power of negative 1.432, we should get approximately 0.037, and sure enough, it's very close to 0.037. Okay, so that 0.037 is approximately 10 to the negative 1.432. And if you just went ahead and took the log of 0.037, you can see we would get that same value. So there's lots of ways to go about getting it. Finally, let's do the e. So we'd have to take the natural log of 0.037. And that is roughly negative 3.297. So 0.037 is roughly e to the negative 3.297. Okay. So for the ones where we have a common logarithm, because we have a base 10 number system, all you need is a related log, and you should be able to figure them out without a calculator. When you have base e, you're probably going to have to just use a calculator for all of those ones. Okay, so enjoy the log problems.